Okie dokie. It is 8 o'clock. Fantastic.
It's very fantastic.
Yes.
8 is one of my favorite numbers.
I know. Well, I don't. Alright. So, it is currently 8 o'clock. Thank you very much for tuning in. This is Spaced Out number 3. My name is Alejandro Arroyo. I will be your host tonight, and joining me tonight will be...
Patrick, howdy. Design team lead for SEDS. How you doing?
Yep. So Patrick is going to be here with me. We're going to talk about space news. We're going to talk about SED's upcoming design team, which is relatively newsworthy. And we're going to be talking about some other stuff too, just miscellaneous. So let's get started.
You should feel lucky I had to turn on CNN and Fox for this. So
Turn on or off?
No, turn them down. I mean, come on, man. What do you think?
Okay. Well, first up is the most important news item of the weekend and the week. Something so fantastically spectacular that it is just way, way too amazing.
You're giving me these eyes like I'm not sure I understand what you're referring to.
It's huge. Literally, it's huge. That's right, boys and girls. We're getting a star... Just kidding. No, we're not. This is completely Photoshopped.
Okay. You got him again, Alejandro.
This was Elon Musk's prank of the year.
The fully steel starship.
Yeah, so this is a Photoshop of 3 super heavy boosters with 1 starship on top when it's just supposed to be 1 super heavy. Obviously, this is not going to happen.
Pranked, lol.
Yeah, pranked. Like, get pranked, right? Oh my god. Like, it would be awesome if this was real, but, that'd be, it's 31 engines per booster, times 3 is 93 engines operating at the same time. And then, they had to deal with so many problems with Falcon Heavy and the structural integrity of that one with only 27 and oh my god, yeah. No, this is going to be... This would be just insane. So
that would be like, letting like Kerbal Space Program do all the
all
the design, just everything. Because, dude, I mean, that I feel like that would
this
go.
Is that's it. This is Starship. 1 second, let me.
Starship Kerbal Edition.
This is the Kerbal Edition right here. Okie dokie. I don't know how to do split screen, so I'm going to be looking over your comments. Let's see. KSSO Nada. Interesting. What kind of acid you have? What the hell?
I think you're looking at the comments of the song.
This is the wrong one.
Nice.
My bad.
Good.
My bad. Okay. Completely disregard everything I just said. Alright, moving on now.
Oh my god.
Okay, wrong one.
Nice.
Yeah, okay, shush, alright.
This is a professional organization.
Okay. In complete seriousness, we're actually going to be talking about Starship. Currently, there is confusion from everybody as to why Starship is being built out of stainless steel. And so Elon gave a little bit of an explanation through this Popular Mechanics article. We'll link it in an email being sent out. But basically what he's saying is that carbon fiber, the original idea for carbon fiber for the entire structure of Starship was just way too expensive.
Uh-huh.
I mean, it's like $135 per kilogram. That's ridiculous, right? So the 35% scrap rate, 60 to 120 plies. So that's like the actual layering of the carbon fiber, high strength resin and all that. And he goes on to mention the fact that steel, high quality stainless steel, keeps its strength relatively compared to carbon fiber at cryogenic temperatures, which is fantastic.
Mm-hmm.
Because when you're in a rocket running off of liquid methane, that's useful
to
be strong at liquid methane temperatures. So
I mean, it would be impressive for the rocket to blow up, but I'm assuming that's not what they're going for. Right?
No, that definitely is not. I mean, it's impressive, but no.
All the people that make YouTube compilations of rockets blowing up would just go over the moon, you know, like
get out. Yeah, so like the stainless steel thing, it's super cool. We have no idea how like it's really gonna work because Elon Musk has to give his presentation. Let's see. Someone said technically stronger cryogenic. Can't remember. Yeah. So yeah, that's the thing that we've got here. And by the way, I'm looking at the comment section for you guys. So if you want to leave some questions, go ahead and hit the comments.
You just made them witness some really trippy stuff.
Oh yeah.
I hope you realize that.
Hey, this is what computers are for.
Yeah.
So let's see. Anyway, this huge, stainless steel structure for the Starship design. This is obviously Starhopper. So this is the test article that they're going to be using to test vertical takeoff and landing with their Raptor engines and the whole basic aerodynamic design. The whole stainless steel structure of the official Starship, which will look like this. Stainless steel. So it's going to look kind of like this, which is just absolutely insane to think about. The usual Reddit, right?
Of
so,
course.
I mean, look at that. It's just absolutely gorgeous. And apparently, I heard a rumor that there's going to be gold on the windows to protect against, what's it called? Against heat and radiative effects. So it's literally going to be the Starship Heart of Gold from Hitchhiker's Guide to the Galaxy.
See, that's so interesting to me how they didn't do carbon fiber because it was so expensive. But then they're like, you know what? Screw it. We're going to put gold on the windows.
Well, I mean, that's just a rumor, so we don't know. But that would be amazing. That would be super cool.
Well, I mean, gold is actually like widely used in a lot of applications for its heat shielding. For example, in I think the Bugatti Veyron used to be the world's
McLaren
fastest.
F1.
Yeah.
Back in the late 90s.
Yeah. So it's it wouldn't be too out of the ordinary for them to do that. But.
Yeah, crazy ass stuff, and of course you have like apparently the Super Heavy is also supposed to be stainless steel. I don't know for sure, but assuming that they're going to be building Starship out of stainless steel, they'll probably use the same kind of what's it called? That's where the savings go.
Yeah.
Indeed, man, indeed. Like it's logical that they'll carry over the same building facilities for the 9-meter Starship to build the 9-meter Super Heavy. No one expected it to die by wind. Yes, we'll be getting to that. But give me a second. So, yes, I'll wing it, Popular Mechanics. Thank you very much. So yeah, that's going to be what it looks like. And according to Elon, when it's going to be re-entering the atmosphere, it will look like a shooting star of liquid silver. Like a giant, bright, liquid silver star. Oh my god, like I am so ready for that. I am so ready. I am so ready to take pictures of that and get my eyes burned by the brightness and the glory.
Alejandro, how are you going to take a picture if you're going to be on the rocket?
That's right.
Yeah,
that's right. That's right.
Alejandro, you gotta be thinking big, man.
Positivity. Okay, so that's a little bit enough about that bit. We'll link the article. Let's see. Types of stars I won't be here in a billion years. Yes. So I found this earlier in the week. This was a Smithsonian Magazine article about stars. So SEDS is not just about SpaceX and spaceships. We're also about, astrophysics and stars and stuff like that. So, I like looking at these kinds of articles, and we'll probably be going over a little bit of this with Liam. Liam is our outreach officer, and he is our resident physics student and astronomy guru. So
he has a big telescope.
Yeah, he has a big telescope, and we'll probably go over this next week when he's on. But these are different kinds of stars. A frozen star. I didn't get time to read this, but so-called frozen stars would churn only 273 degrees Kelvin, which
Wow.
is 0... Wait. Oh, okay.
Yeah,
So
literally.
0 degrees Celsius, filled with various heavy elements due to scarcity of hydrogen and helium in the cosmos. So, so this would be like later on in the history of the universe when like it's almost like heat death almost. So you'd have something like this.
Interesting. In the heat death, it gets really cold.
Yes.
It's
yes.
quite ironic, isn't it?
Heat death. I mean, yeah, ironic because of the name, I guess. Yeah. True. Let's see. The Iron Star. Ooh.
Oh yeah.
Ooh.
Dude, it's honestly kind of like... I was talking to a professor years ago about how stars, how they die. Essentially, he was telling me that when they're going through the process of either turning into a supernova or just turning into like a dwarf or just a black hole,
Yeah.
what happens is that sometimes they start like just rapidly channeling through different elements, and essentially they become composed of different elements.
Yeah, I actually took a class on this.
Really?
Yeah, last semester. Astronomy 401, for anyone who wants to take a super cool astronomy class. We got it from Dr. Louis Strigari last semester. He only teaches undergrad like every other year. But he was going over that, and we learned about how the carbon-nitrogen cycle operates, how stars collapse, how they start... let's see. God, the winter break wiped out my memory. Right? Hashtag college, right?
Some would say that's a good thing, just considering how last semester went for some of us.
Oh man. But let's see. Yeah, so stars, as they get older, they burn through their hydrogen and helium reserves, and so they first burn through the hydrogen, get through, start burning helium in the core with hydrogen shells on top, and it continues going like that, where the current element being burned is in the center, and you have shells of the previous elements on the surface of that interior. So it's kind of like a layered cake almost. Eventually you get until carbon nitrogen for some stars, heavier elements for heavier stars obviously, but the ones that go supernova, so supernovas are type 1, type 1a, type 1b, type 1c, and then there's type 2 supernovas. Type 1s are where you have stars that collapse in on themselves to become a white dwarf, but they don't explode necessarily. They're just going to expel a lot of material and turn into a planetary nebula. So, yeah, planetary.
Nice.
Yeah. My brain gave up halfway through the sentence. So they create something like this. So you have like a white dwarf in the middle of this, or a small star remnant. Now, type 2 supernovas are more like this, where you have a massive, massive star that collapses in on itself right when it like gets to the iron part, because if you study some quantum mechanics and like serious physics, you learn that once you start fusing elements of iron, the iron, like the process becomes endothermic.
Oh.
I believe, not exothermic. So it produces, it costs more energy to fuse the iron than what is released. So with hydrogen and helium and those lighter elements, when you fuse those elements, it takes less energy from the star to put them together and make them explode versus the energy that's released from the reaction. So you have like a good example is like the current efforts to create a fusion reactor. If you guys search it up, there are tokamak reactors, there are impact reactors, laser fusion reactors, where they're trying to beam a laser and blow something up with that laser and heat it up like a hydrogen
I like
pellet.
that one.
Yeah, that I think a Sandia National Labs is doing that one. It's the most powerful.
Sandia means watermelon in Spanish.
Sa-
Continue.
Okay, that's all right. Random facts.
We're going to be learning about a lot of different things today.
Watermelon. All right, sweet. But anyway, so you have different types of fusion reactors nowadays, and that's the key. That chemical or not really chemical, that nuclear reaction of causing more release of energy than what you're putting in. And that's the problem with current fusion reactors on Earth, is that you're taking more energy to cause the plasma inside of the reactor than what is being released by the plasma. So For example, one big project that is very slow moving but is kind of getting there is ITER. So ITER is a gigantic fusion reactor based off of the tokamak donut design. Yeah, this thing is massive. When I say it's massive, I mean this area right here. For usual small tokamak reactors, there may be like a couple feet across tops. This one is going to be big enough to stand in and like maneuver around in and do stuff in. Like, let's see. This was the prototype. So this was, let's see, Kotar, Keter. I don't know. This was apparently to the Japanese one, but let's see. There's the building for ITER. It's kind of small. This is the building for ITER, and as you can see, like, it's pretty huge. I think that's a generator over there. Yeah.
And this is still for research purposes or for commercial
This
purposes?
is research. So,
Okay.
yeah, tens and tens of billions. K-Star. Thank you, Supple Nuts. Nice name, by the way. Multi-billion-dollar effort by European nations.
Squirrels love him.
So it's funded by the EU. Yes, question mark, friend. Question mark. Yeah, it's funded by the EU. So, you know, there's like Germany, France, UK, Spain. I forgot all the partner nations. But it's a pretty big effort. And then, of course, you have laser fusion, most powerful laser, I think. I forgot the name of the lab. Most powerful laser, Osaka, fast ignition experiments. Oh, it's in Osaka. Whoops. Okay, my bad. I'm dumb. Wait, then what was it? Sandia National Laboratories Sun Laser, right? Laze. Directed energy laser off. Okay, we'll table this discussion for later. But yeah, so fancy stars. We'll talk about it a little bit more with Liam because I need to read up on this. But you know, trillions and trillions of years. So that just brings up like the heat death of the universe and what's going to happen billions and billions, hundreds of billions of years from now when you know the galaxies all move away from each other due to the expansion of the universe.
Not even the galaxies, every particle. So it's like no interaction between particles.
Well, that's like way down the line. That's like trillions and trillions and trillions of years from now, according to some
according to some theories. Yeah.
Yeah, because I mean there are different theories where
Big Crunch.
Yeah, Big Crunch, the big rip. That's what we're talking about. You know, everything gets ripped apart, and then there's in between where it may just equalize. Who knows? But that's the idea, and the answers to those questions will provide insight on the general physics of the universe, and we will understand a little bit more about how the universe works than we do now. So these kinds of stars are pretty cool to posit and kind of think about, and so we'll talk about that later on next week. For space news, in terms of just regular space news, Delta IV Heavy lifted off on Saturday morning at 11:10 a.m. They were launching NROL 71, top secret satellite for the National Reconnaissance Office. And these satellites, we talked about it last week with Connor, and these satellites are probably geophysics satellites, tracking submarines, taking spy satellite data, thermal data, who knows, and maybe communications for the military, all that. So it's really, really crazy, really, really insane stuff. But of course, it provides a good spectacle when it launches. On the
and it
Delta
wasn't
V.
canceled 10 minutes before launch.
Thank God. Yeah. That infamous day in my history. Oh God. For background,
I'm here for you.
for background, I was once gonna watch a space shuttle flight. It was the second last space shuttle flight, and it was canceled 10 minutes before because a rainstorm hit Florida, and my day was ruined.
Do you remember what shuttle it was?
No, actually. All I know is that it was one of the very last shuttle flights, probably the second to last one.
Because I know the last one was Endeavour. Man, the
last one was Atlantis, wasn't it?
No, I thought it was Endeavour because I remember watching it.
Atlantis. Okay, we're not going to the Bahamas this week.
Not this week. But...
Yeah, pay your dues And we may be able to afford a trip to the virtual Bahamas using the VR lab.
Yeah.
Let's see. Yeah, space shuttle. Yeah, last flight STS-135.
What the heck?
Yeah, so maybe I was gonna watch
Endeavor. What?
Yeah, final mission STS-134.
Oh, you were gonna watch Endeavor. Okay,
maybe
yeah,
I was gonna watch Endeavor.
yeah.
That
Okay,
was probably
there you
it. Yeah, I was probably gonna watch Endeavor.
Okay.
So, then it got delayed, and my life sucked for a week.
See, I got to watch it in the morning, like at 6 a.m. It was really cool. You know, I didn't I didn't sit on any rocks.
That's
know.
amazing. All right, moving on. Yeah. Anyway, by the way, for anyone wondering, yes, that is black brown char on the outside insulation of that Delta IV
Left
Heavy.
it on the grill too long.
I mean, I guess. Yeah. They left it on the grill too long. Yeah.
But as you were gonna say what it is.
No, that's really okay. Fine. The real explanation is the engines on the Delta IV Heavy are the RS-68As or some RS-68s, and they operate on liquid hydrogen, liquid oxygen, and the liquid hydrogen, since they're flowing. It's a fuel-rich cycle, I believe. Let's see, RS-68. So liquid fuel engine, gas generator. Is the largest hydrogen-fueled rocket in the world. Performance, yes. Okay, it doesn't give too much information. But it's a hydrogen gas generator cycle. It flows the hydrogen early before it flows the liquid oxygen. So that means that it has a lot of hydrogen in like kind of a cloud, an invisible cloud around the bottom of the rocket. And to ignite it, they shoot sparks into the cloud.
Like the space shuttle.
Yeah. And so they ignite the excess hydrogen, and you have the giant fireball, right? And that's actually one of the reasons why the RS-68 is not human rated and why the Delta IV Heavy is not human rated, because they'd have to fix that like they did on the space shuttle, so that you won't have, huge plumes of fire flying around the rocket during launch.
We could show them what it looks like on the space shuttle. It's actually like really, really interesting once you actually know what it is, because you've probably seen it 1,000 times, but to really like, even to the most minute detail, to be able to watch that, it's honestly just mind-boggling.
Right, so here it is. Right before launch, they fire the sparks to ignite the hydrogen or any excess hydrogen, and then you have, these are the RS-25 engines, developed by Rocketdyne, and of course, wow, awesome! It's amazing,
dude.
Yeah, that's the best launch video right there. But on Delta IV Heavy, you have a little bit different. Let's see. So in this case, you have the launch right here. It doesn't have a countdown anywhere nearby. You have the smoke rising, right? Let's see, when does it go? Okay.
Oh!
There we go. A giant fireball, so they cut. You see the fireball, and then it starts. So that fireball, they cut it out probably for PR reasons. But, so that they don't get caught, lighting their own rocket on fire. Oh. But, yeah, they launch it, and then the fire goes away and everything, but you still have that char on the outside of that orange
The nice
tank.
even char on the outside,
Just like your best steak.
Yeah.
This rocket is a steak.
Yeah? Sure.
Yep. We'll leave it at that. Blue Origin. All right, so Blue Origin launched their rocket on Monday. It was their 10th launch, so NS-10.
The New Shepard? Oh, yeah.
Yep, on the 23rd, so that was... Oh, wait, no, not Monday. Wednesday.
Oh, dang.
So, I don't know my week. Yes, this week has been weird. So they launched their rocket on Wednesday. And it launched around 9:05, 9:10 a.m. T-minus 1, 2, and we have liftoff.
Not yet. You jumped the gun a little too soon, Alejandro.
Oh, okay. Well, I mean...
we have liftoff.
Now we have... Okay, shut up. Clear the tower, whatever. So... Alright, there we go. Woo! So...
See, when it starts going up, Alejandro,
Yes.
That's
That's liftoff. I got it. All right, I got it. So it's going to approach max Q, punching through the atmosphere pretty fast. It's powered by a single BE3 engine running off of RP1 and liquid oxygen. Let me check up on that to make sure. The BE3 liquid hydrogen, liquid oxygen. Oh, it's not an RP1 engine. Okay, so it's it's Hydrolox engine, and it's a single stage. Not a single stage to orbit, but just a single stage rocket.
So this is not the completed version, I'm assuming.
No. This is just this is technically the completed version, but it's the completed version of New Shepard.
Okay.
So New Shepard is just their tourist rocket. This is the one that's going to be going up to 100 kilometers, and then that'll be it.
So this one isn't going to go into orbit?
No, this is just for your average Joe. Average Joe being someone who can afford a thousands and thousands of dollar ticket to go into space for 5 minutes.
So hence the name New Shepard.
Yeah, New Shepard, and
Shepard.
then their eventual rocket for orbit is New Glenn. We'll
see that makes sense. Yeah.
New Glenn would. Yeah, actually that does make sense.
Yeah, because Alan Shepard, he was the first man in space, but he didn't go in orbit.
Right.
John Glenn was the first man in orbit, so that makes sense why they would call it that.
John Glenn. Yep. So separation.
Nerds.
So separation of the capsule and the rocket. Just having there, so 250 or whatever. Still going over 1,000 miles an hour. They're going to head over to Apogee right there.
No, there. Oh.
Yep. So their apogee was around 351,000 feet, which is pretty high.
Yeah, that's actually
space.
Yeah, that's
I believe.
Right? Isn't 350,000?
Let's see. It's 1.6 kilometers per mile.
We can Google it.
So, no.
Okay.
775 divided by 5280. So it was 66 miles.
So yeah, that's space.
That should be space is 62 miles. So,
yeah. Okay. Yeah.
Okay. Yeah, I'm not going to use Google. What do you? No.
I mean, some would argue that space is 100 miles, but I mean, who cares?
No. Space is space is 62 miles. It used to be 50 miles. The Air Force wanted it to be 50 miles, but then when NASA came about, actually, this is a super cool part. So let me just turn on the noise here.
They do hovering, right?
Wait, 1 second. Ready?
Okay.
It's coming down.
I can see New Shepard right over my shoulder. She is coming in. Boom! There we go.
Woo! So yeah, they landed the rocket. It was super dope, and they did the hover. So it's a little different from
SpaceX.
Yeah, SpaceX, because their rocket, their engine is much, much more powerful. A single Merlin engine is capable of going positive thrust-to-weight ratio on a partially fueled Falcon 9 booster. So they have to do something called a hover slam, which means it's literally doing, for anyone playing Kerbal, it's a suicide landing, suicide descent, and that means that they have to start the engine right at the moment that if they had started any later, they would crash. So they have to slow down at exactly the pace that the engine is slowing down and have to match 0 miles an hour with 0 altitude.
Yeah.
And it's super, super difficult, of course, because if they get it wrong, it'll hover at 5 feet above the pad and then start taking off. Because the engine is more powerful than what the actual booster weighs on landing. So that means that if they don't get it right, it'll hover and then they'll have to cut the engine and it'll slam down on the legs. They do have crush cores, as they call it, to kind of like suspension elements, shock absorbers, and there's landing. But like they don't want to use crush cores too often because it may damage the rocket. So 10-minute, 16-second flight. That's what you would expect if you paid, tens of thousands of dollars to go on this rocket. No price availability, of course, no ticket availability because no one really knows when they're going to start flying people. Blue Origin's super secretive. All we know is that they are intending to fly people by the end of the year, and they are intending to do test flights sometime, like probably summer or fall or something.
See, watching how close they are to actually pulling this off is really interesting because it kind of contradicts what we were told at Space Vision, where essentially space tourism was dead, whereas Adventure it was dead. And that's why whenever I see stuff like this, I always think about that because clearly it's not.
Yeah.
You know, clearly like there's a lot of interest. Clearly like they're targeting a end of 2019 deadline.
Yeah.
So it's I wonder why he said that or why they said that.
I think the buzz is out. The buzz is gone for space tourism because it was super amazing. 100,000. By the way, we're also streaming on Twitch. Let's see, Space Nicole, 100,000 maybe for the price of the ticket. I would say, I mean, that's probably what it's going to be around in the hundreds of thousands. I know Virgin Galactic charged $250,000 for their tickets, but then again, $250,000, that's a lot of money.
Yeah,
so only rich people, millionaires and stuff like that are going to be able to buy it firsthand. I'm expecting it to get down to the tens of thousands, probably by the mid-2020s. At least I'm hoping. Because if they're going to be running these... I mean, obviously Blue Origin can reuse this rocket. That was the third or fourth rocket launch for that booster and for that capsule. So if they can reuse it, and all they have to do is just refuel, because it doesn't have to go through the ridiculous heating cycle that a booster from... that a Falcon 9 has to go through, you know, traveling through the atmosphere at 3,500 miles an hour. Yeah, fingers crossed indeed, Space Nicole. Like, the Falcon 9 has to go in through the atmosphere at, like, 3,500 miles an hour. Like, they have to deal with a lot of heat on the bottom and stuff.
See, you know, the really, really cool way that they deal with the heat, you can actually, like, watch the videos right now, is that essentially what they do is that they create a force field with their thrusters. And so they yes.
Well, I mean, that's the braking burn. When they come in right before they hit the atmosphere, they brake just a tad bit so that it doesn't destroy everything. And then they also do the liquid cooling on the bottom. Fun fact, they do actually run water liquid cooling on the bottom of a Falcon 9 to make sure that everything is spick and span.
So that's essentially evidence that Elon Musk is a PC gamer, right? Indeed.
All right. Apologies for those looking at the document there.
They just got a behind the scenes look.
I know.
Man, if only they knew.
So yeah, I mean, hundreds of thousands of dollars probably, but like it's a fully reusable spacecraft, and it's not like the Virgin Galactic spacecraft, because that one uses a hybrid nitrous oxide and rubber engine. So it's a hybrid solid and liquid fuel engine, and the issue with that is, like, you have to replace that rubber, right? And you have to replace all of that material. So it's like a canister. You have to slide it in, but it's not an easily replaceable canister, I don't think. So, like this one with New Shepard and Blue Origin, all they have to do is just land it, move it back over. Maybe like they'd have to do it like twice a day instead of like 10 times a day. But all they have to do is just refuel. They don't have to redo like random stuff. You know, they can just kind of like what Elon Musk wants to do with Starship. Just land it on the launch pad, have a crane, put the new capsule on top, load people, and go.
See, but also, I think mid 2020s for like tens of thousands as the price tag, I feel like is a little bit optimistic.
Yeah.
Just because to me, I mean, you also have to consider like the commercial viability just right now in terms of supply and demand. Because of course, there's only so many people that actually have enough income to pay the $250,000 price tag around there. Because you know that they didn't just throw out $250,000 for no reason. Because if they invested all that time and money into actually developing their vehicle, they're not really gonna like just be like $250,000. They're gonna be like, okay, so this is approximately how much it's gonna cost to launch it in orbit and how much it's gonna cost to bring it back down, you know. And so I think that for it to really be $10,000 or in the tens of thousands, I think there needs to be a very like revolutionary approach in the way we do space tourism. Because I think right now it's still very much in its infancy. For like, of course, obviously, it's still very much in its infancy. Hence the extreme price tag. Because I mean,
yeah.
I don't know about you. I'd pay $250,000.
Yeah, I'd pay that. I mean, it's better than paying $20 million to go to the ISS, or $40 million for the ISS, right?
Well, I mean, wait. I thought they boosted it up to like $80 million or something.
No way.
Yeah, dude, look it up. Like I heard
Russia.
Like, you do.
Russia price for Soyuz seat. 372%. This was in 2016. So this is NASA. I guess we can go off of what. Let's see.
Yeah.
Holy
yeah,
crap,
dude!
you're
It's
right.
$81 million per
What
seat.
the hell? Holy crap! That is a lot.
So,
I thought what? Oh,
I wonder if they come with like those little shotguns that they gave the cosmonauts
Lols.
in the.
Nah, they probably only give that to Russian to cosmonauts.
True.
Okay, well, next up, yes, the Starhopper tipped over. So, apparently, there were some high winds in the general vicinity of Boca Chica, down south in Texas, and the giant Starship, being over 100 feet tall, tipped over because of the winds. It broke its moorings, and let's just say, according to Elon Musk, it will take a few weeks to repair. So any hopes of seeing it fly in the next few days or weeks is now shot. So 50-mile-an-hour winds broke the mooring blocks late last night, and fairing was blown over. Will take a few weeks to repair. Actual tanks are fine. So they did actually put in tanks that were part of the actual Starhopper that will be running the Methalox.
Oh my god.
Huh? Oh yeah. Sorry, we're looking at the chat right now. Wow. Yes, over 50 trucks reported at Boca Chica, according to the comments. Yes, there was a lot of activity, and there actually is a 24-hour live stream. Boca Chica. Boca Chiac. There we go. This live stream is not recording. All right, sweet. Okay, I don't want to learn how to do that. I'm doing that right now. So there was a live stream going on, and let's see. Yeah, there we go.
Is.
Yeah, 8:36 p.m. So if you guys want to go watch it, this is what it looks like right now, except less grainy.
It's so beautiful.
I know. Look at those 3 dots and the yellows. Oh my gosh.
It looks like, you remember, have you heard of like the Phoenix Lights?
Like
the alien,
no,
the quote-unquote aliens
no,
over Phoenix.
please. We're only getting SEDS onto the national spotlight now. We don't need, we don't need conspiracy theories.
This is what SEDS is actually about. Welcome to SEDS
They're
After
watching.
Dark.
They're watching us. Ah! Okay.
You can't trust anyone.
You gotta protect yourself against the Y rays, dude.
The
They
what?
fry your brain, man.
I heard that like they put the rumor out there that tinfoil hats fuck, you know what? I can't talk.
You can't talk. Just stop.
I
It's
need,
okay.
I need
It's
to
okay.
practice my stoner accent because I don't even know what they're gonna say.
Okay. Well, while you're working on that, we'll go to the lunar eclipse.
Screw aerospace engineering. That's where it's at.
Go to California, right? No, don't do that. Please don't. Okay. I have reached my limit of free art. See, you know what? You know what? Fine.
Nice.
Screw you. You lost a friend. New York Times, you lost a friend. Okay. So, during the lunar eclipse on Sunday night, there was an event. No one knows exactly what happened. It may have been aliens, alright? There's a point zero 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 like infinity 0.1 chance that it's aliens.
So you're saying there's a chance.
Alright, yes, there is a chance. But apparently there was a small meteorite impact on the moon during the actual lunar eclipse. We didn't actually see it. Oh. Can you guys hear us? Oh, okay, got it. Too loud for the audio. We'll go ahead and bring down the microphone. Hopefully that's a little bit better. Let's see. Yeah. Okay. Sorry guys if we're kind of blowing your ears out, but I'm still getting the hang of this OBS stream setup. Still getting the hang of the microphones. The video audio was too loud. Okay. Then we'll fix that in a later podcast. I'll make sure to put some settings in. Anyway, continuing. Let's see. This is the wrong page.
Oh, voice soft.
Voice soft now.
We have
Thank you.
overcorrected.
Okay, sorry. These are the guys on the voice chat or the chat for
Twitch.
for Twitch. So those on YouTube, sorry, I'm monitoring you as well. Don't get too close to the microphone, otherwise you're gonna blow them out.
Is this better? Are you?
Yes, is this better? We can go ahead, get closer to the microphone.
Welcome to
Oh, okay.
Space News.
Played was louder than your voice. Oh, interesting. Okay, cool.
The mic is
Cool. Okay,
supple nuts.
Yeah, we'll keep it here.
He's really living up to
sexy
their
voice. Look at this. Okay, all right. So we'll keep it there. Let's see. Okay, wrong page. False. Yeah. So the lunar eclipse happened without a hitch, other than that meteorite impact. That was really cool. I think some satellites are currently going over that. Let's see. Lunar eclipse, meteorite.
And if you went to the said social event during this, you might have caught it.
Yes, indeed.
I mean, probably not, because everyone was having too much fun talking and
Yeah, I
hanging
mean,
out.
it was a split second
Yeah.
occurrence, so who knows. Let's see. The combination of a darkened surface and a lot of people watching made it much more likely that the flash of the impact was seen, and it reminds us that the solar system is still a very dynamic place. Yeah, there's a lot of stuff flying around the solar system, not just our orbit and all the dead satellites and everything. Like, there's a crap ton of stuff flying around the solar system waiting to just hit something. So, this just reminds us that the moon does get impacted with stuff. And I'm actually doing a bit of a project regarding lunar regolith, and that's how lunar regolith is made. The upper layer is billions of years of impacts, where the impact causes the outer layer to melt, the bedrock to melt, spray out, and when it cools, it creates something called breccia, lunar melt, essentially melted rock. So yeah, nice socks, by the way.
Thank
Patrick
you.
is showing me his socks, and they're very, very nice socks.
See, they're Christmas socks, and I don't know. I think it's still a little cold, so I'm not out of the loop just yet.
Okay, whatever.
Hey,
It's a month after, Patrick, but okay.
I mean, you might think that Santa Claus was even the first man in space.
Maybe.
So, I mean, I'm just representing right now.
Maybe. Are we still getting SED's socks, according to the Twitch chat?
Oh.
Like we rightly should. We are going to look into it. We are also looking into that, the Elon Musk promise of steel underpants. That is just what I'm saying. I don't know if that we're officially looking into that, but we will look into such things because, the world deserves both space socks and steel underpants.
How would you wash steel underpants, though? Like, do you just get a hose and just or
Put
buff it?
Put it in the oven. And buff it, yeah, buff it.
Put it in the oven, dude. Oh
Yeah. All right.
Oh, man.
But anyway,
don't put it on when it's too hot.
okay.
Oh.
So the last thing we're going to talk about today is Ultima Thule. So Ultima Thule was visited by what's it called? New Horizons, right? It was visited by New Horizons a couple weeks ago, and this is a better, more high resolution picture of what Ultima Thule looks like. So it's essentially a very misshapen and lumpy snowman. And the structure is actually very similar. It's two separate, clumps that came together under their own gravity and is thus joined right here. It's basically a snowman. Yeah, smaller ball with bigger ball, and I guess your socks are making everything good because Christmas and snow and
Yeah, it's a snowman.
Oh my!
See,
God.
Alejandro, I'm like 10 million steps ahead.
You're 10 steps ahead. Right now.
I'm sorry,
I got
man.
it. So yeah, Ultima Thule. Let's see. Is there any new information about it? There's KBO, 4,200 miles from the spacecraft at 12:26 a.m. Eastern Standard Time on January 1st. 7 minutes before closest approach. Original resolution of 400 feet per pixel. The image was stored in the spacecraft's data memory and transmitted to Earth on January 18th through 19th. So you have to realize that, these pictures are sent through ridiculously small pipelines for bandwidth. And, radio signals traveling billions and billions of miles. So it's difficult to send these kinds of high resolution pictures quickly. So we're going to be seeing a lot more of this data dump as the weeks go on from New Horizons and from the Deep Space Network. And we can talk about it a little bit with Liam next week regarding the astronomical significance of this. But generally speaking, it's just, this isn't the Kuiper Belt. This is way, way out there. 4.13 billion miles is where the New Horizons is. It's about 4 billion miles of this Ultima Thule object. And being so far away, being so far away, these objects are essentially time capsules from the beginning of the solar system. They've never been touched by anything else. And it's so far away from the sun, so far away from comets and all that dust and everything. Like, there's no interference with what was originally in these objects. Mm-hmm. So these things are literally 4.5 billion years old through and through. So we'll probably get more science, and we'll get more news dumps, news flashes from all the scientific journals and everything over the next year from data being delivered by New Horizons. And that's exciting.
But looking at asteroids and the like, I want to kind of get your perspective on this, because you know how we were talking about space tourism and the commercial aspect of space.
Yeah.
What about space mining and the ideas of actually bringing these asteroids closer to into our orbit and essentially mining them for resources? What are your thoughts on that?
Well, I mean, I'm one of the projects that I'm doing right now is regarding space mining and regolith mining. And a lot of the issues is that we've never really done straight up space mining before. We've done, cores. We've done sample gathering from the moon. We know how to drill a little bit from Mars rovers. The current InSight lander, Phoenix, the Phoenix rover. So let's see. Oh, this was the Phoenix lander. Sojourner, I think, right?
Oh, Sojourner. Wow.
My bad. All right. Yeah. So, this little rover had a little implement on the very end of it that could actually, sample a rock and look at its composition.
Wait, was that the laser? Or was that the one in Curiosity?
That's Curiosity.
Yeah, Curiosity, yeah.
So this was an early. So Pathfinder rover, Sojourner. So if you guys remember The Martian, Pathfinder was the actual lander. This was the rover that was included on the lander that Mark Watney used as kind of help to communicate with the rover and stuff like that. So this little rover did have a little implement for gathering samples. You do have the laser, the ChemCam. So the ChemCam on Curiosity, that tool is capable of shooting a laser and kind of burning a bit of rock, and then the actual camera analyzes the debris off of that rock as a way to measure the spectra and watch like what chemicals, what compounds are in that dust. And that's how it determines samples from a remote sensing kind of way. I say remote sensing very, very tentatively because like remote sensing is supposed to not alter what the object you're studying is, but in this case it does alter it. So, you're shooting lasers at it. So
yeah, I mean that's
a little bit that's altering a little bit. So yeah, like we've done some sample gathering, some drilling, very, very little in terms of off-world regolith, that's the dust, off-world materials, rocks and stuff like that. But we've never actually done it like full on with an actual machine, like actually drilling into the ground deep, putting in pipes, getting samples and materials and resources out of the ground. We've never done it on asteroids, and like that's a real issue that I've been finding in a lot of the research, the background research that I'm doing for my project. A lot of it is like we have to figure out how to deal with first the regolith itself. The regolith itself has different consistencies, different properties. When you're drilling into it, How much force do you need to apply? How are you going to deal with the rocks that are getting or the dust and debris that's getting thrown out from the drilling point? Because, when you're on Earth, you have gravity and the wind to keep stuff from flying all over the place. But when you're on the moon, 1/6 gravity, no air resistance, so it's just going to fly everywhere. And you're going to have even more problems than the Apollo astronauts did with their moon suits getting covered in dust. So you have to figure out how is that going to affect the machines that you're using. Is that going to gum up the drivetrain for the drill? Is that going to cause a static electricity discharge that, disables some of the electronics on your drilling rig or something like that? You have to figure out the chemical content of the regolith you're using. Branch mining, I'll search that up in just a second. But you have to figure out what the chemicals that you're going to use. What are the chemicals that you're going to use in the actual regolith? And you don't really know that until you get the data and you actually go there and see. And we have a lot of data, we have a lot of ideas of what it is, but you're not really going to know until you get there, of course.
Yeah.
So we need to do more testing, more sample gathering, and that's the general consensus right now. With the advent of commercial companies launching to low Earth orbit, to the moon maybe, to Mars hopefully, these kinds of experiments will get a lot of traction, and finally there will be an incentive to start really studying mining on other planets. So, as with most things in space, it's 5 years out, it's 10 years out. But with space mining, we have the technology.
We have the technology.
We have the technology.
We can rebuild it.
Yeah, we know the general theory. It's the practical and logistical things that we have to figure out.
And the funding.
Funding, of course.
Yeah.
But that's with everything, and it's just logistics at this point. Figuring out how to deal with unforeseen circumstances while doing it, and how to make sure you don't screw up, because that's the real thing. You don't want to get a multi-billion-dollar mission to Mars and then find out that your rover can't drill because the dust on Mars causes some magnetic anomaly and it makes the motor go haywire.
And also, you don't want to get an asteroid, bring it closer to Earth and then accidentally kill it.
Oh yeah, asteroids. Yeah, that's it. Asteroids. The problem with asteroids is that a lot of them are very loose. So the regolith.
They get around.
Huh?
Never mind. Continue.
Well, yeah, they you can't really maneuver on them.
Mm-hmm.
You have to fly around them pretty much, and it's the current OSIRIS-REx and a couple other satellites that are currently flying around asteroids out in space right now. Those satellites are having to maneuver around with their thrusters because they can't land. There's no gravity on those things. It's essentially zero gravity. So they're having to basically fly around the asteroid one point to another. So you have to figure out, how am I going to tether myself to the asteroid while I'm drilling? Because Newton's laws, equal and opposite reaction.
Has an equal and opposite.
So if you input a drill into your lunar regolith or something like that, you're going to get an equal and opposite reaction force that pushes you off the asteroid. 50 meter per second orbit, LOL, on one of the comments. Yeah, so it's a super slow orbit. Let's see. Current asteroid satellites. Or satellite missions. Current missions, InSight. Astro ASO. There's another one. Dang. I really need to get my I need to redo my space knowledge. Gosh. Yeah, let's just go with OSIRIS-REx then.
OSIRIS-REx.
OSIRIS-REx.
That's a protagonist name if I've ever heard one.
Yeah, so it's flying around Bennu right now, and it's actually kind of cool. This satellite is just flying around in a kind of square orbit, essentially. So it had to rendezvous with Bennu, and this is its orbit. It's maneuvering around and it's using its thrusters to basically move very, very slowly. There it goes. It encounters Bennu, slows down, and then kind of just putters around for a little while. It's doing this as a way to study the asteroid before it actually lands on it to gather a sample. But this is its orbit, and it's not like any other orbit because obviously Bennu has such low gravity that you can just move around like it's basically zero gravity. And that's the thing. Like when you're trying to mine something, you don't want to be flying around like this. You want to be on the asteroid, obviously. And you can't like punch into the asteroid and then fly off into the distance because your drill isn't correctly held down. And moving it closer to Earth, like Bennu... Yeah. 900 feet. So you're moving a 78 billion kilogram... Wow, that's a lot. So 78 million tons. Tons being the metric ton. So 1,000 kilograms, right? So that's I just want to make sure that I'm not completely making an ass of myself right now. 78. So that's 78 billion divided by 1,000. You ever do addition 2 plus something or simple addition?
You check it on the calculator.
Yeah, check it on the calculator. Make sure.
Wait, why did you divide by 1,000?
Because 1 metric ton is 1,000 kilograms.
Oh, okay.
So
okay,
you
yeah.
do 78 billion divided by 1,000, you get 78 million tons. So you're going to be moving a 78 million ton mass around. And, no air resistance to deal with, but inertia.
Yeah.
Pure, unfettered inertia. You're going to have to fight that to get it
Not only
to
do you have to slightly increase its speed, but you're also going to have to use the same amount of energy to slow it down.
Exactly.
So it's...
I mean, you can do... I mean, NASA and JPL, they've got wizards for physicists. They're amazing at their calculations. But generally speaking, like, you'd have to do some very, very calculated, very, very specific maneuvers and gravity assists to get this asteroid anywhere near Earth, and then you'd have to put it into a 70 gigatons. Let's see. Giga is billion, and tons. We're looking at the Twitch chat right now. Giga is is a billion, so this would be 78 trillion kilograms to be 70 gigatons. So this would be 78 megatons of mass, not energy, just mass. You may remember that from like measurements for power of a nuclear bomb, but yeah, this is the mass version. So 78 megatons. It's ridiculous. So you'd have to do some very clever maneuvering of this through gravitational assists to get anywhere near Earth. But then you have to deal with like, what if you crash into the planet?
Yeah. What if you wipe out an entire country?
Yeah.
An entire species.
I don't think Allstate is gonna give you their good hands for that. So.
But see, also you would have to also start considering about how it would affect the environment, just having such a massive object so close to the Earth.
I don't think it would affect, especially if it's at a Lagrange point. So a Lagrange point is a point in space where the gravitational effects of the sun and the Earth cause kind of eddies, points at which you can sit at in orbit that are exactly the same orbital period as Earth itself. So you have L1, L2, L4, L5, and L3. L3 is obviously on the other side of the sun. L4 and L5 are kind of interesting. These points for Jupiter are called the Trojan and the Trojan asteroids. So Jupiter, Lagrange asteroids. There we go. Trojans. Let's see. Yeah, so these are the Trojan asteroids. So L4 and L5 for Jupiter, they have, what is it called? They have huge amounts of asteroids, and this is kind of why we don't really want to go anywhere near these points for Jupiter, and that's why Jupiter's kind of a scary force in the solar system, because, these massive asteroid clumps, I mean, they're far apart, but they're still massive, are very, very scary. And Earth has the same thing. we may not have huge clumps of asteroids, but we do have the same points. And for fun fact, JWST, James Webb Space Telescope, was supposed to be at L2 by now. But as our friend Liam was so sadly say, it's been delayed again.
Oh no.
I mean, it's not. I'm not saying that like it just got delayed, but it's always delayed. So, what is it? This like L2, L1, you could possibly put it, depending on where it is, you could put it at one of these Lagrange points, or you could put it in orbit around the moon. It wouldn't do anything.
But also, wouldn't you have to also consider the idea that it might accidentally block out the light from the sun?
I mean, it's a tiny, tiny little asteroid. It's 900 feet wide, so you might as well. You can do anything with it. The one issue would be like, if you're sending up a satellite and it's in moon orbit, you don't want to hit it, obviously.
Man, you disgusted somebody.
No. I think they're very disgusted with how delayed James Webb is.
Okay.
But yeah, like you can move it, and that's what Obama wanted to do with the asteroid recovery mission, and like it could be done. The problem is it would take 10 years or something equivalent because on that scale, because like you have to slowly move it. We don't have the delta V in a chemical rocket to do that.
Yeah.
So you'd have to do it with an ion engine, which takes years to do anything. And then, or you could use a gravity assist thing, but that's still insane. So,
Asteroid redirect mission.
Yeah.
Somebody call Michael Bay. He knows how to do it.
Somebody called Bruce Willis, right?
Yeah, exactly. What was it? Why did you write it in so that construction workers instead of astronauts went up into space?
Yeah, just shut up.
Didn't he curse them?
Yes, but we'll try to keep this stream a little bit on the down low in terms of that. But yeah, that was a funny.
Hello, Nada.
Hello, Nada. Thank you for joining.
Howdy.
Or howdy,
yeah,
howdy,
yeah.
Nada. Oil drillers, yes, indeed. That was funny. Yeah, that was funny. So yeah, asteroids, we could do it. It's just logistics issues. We don't really know the procedures for it, so we have to do real testing with that, and that's going to take a long time.
But see, well, I think this applies to this as well. But whether you start right now or you start 10 years from now, it's still going to take the same amount of time.
Yeah, no, I'm fully for starting now. The issue is like funding and launchers. We don't have the launchers right now. We don't have the funding for it. So that's just going to take time. So it takes time.
Yeah.
And so space drilling, I don't see it as a real thing until probably the 2030s at the very earliest. With SpaceX going to Mars, on the other hand, you can see that space mining might become a thing for Mars, like in situ resource utilization, drilling to create fuel on Mars for the methane, liquid methane and everything. Those things will be necessary for Mars missions. But again, that's going to be a little while.
But I also think that with the advent of just commercialization of space and all the private companies actually going into their own mini space race, I think it's not as far off as we think. Just because
no, it isn't. Yeah.
Yeah, like the viability of all these things is there. Like all the
technological know-how is there.
Yeah.
The issue is that we can't put it into practice right now, and therefore we can't develop there was this Austrian general that said that no plan ever survives the first encounter with the enemy. And in this case, the enemy is vacuum. The enemy is dealing with problems, and we don't know that yet. So we have to test it out. We have to put those things into practice to really figure out whether or not we're going to be able to do it.
See, if only everyone could take the Elon Musk approach to space development and just like, if it blows up, okay, perfect.
Well, I mean, that's the thing. Like, Elon is a very unique individual in that term because everyone else in the aerospace industry is, very tight-lipped about everything,
especially the government.
Especially failures.
Yeah.
Like, no one wants to show off their failures. Elon Musk, on the other hand, made a freaking highlight reel of his. So, like, he's a different animal compared to others like Blue Origin, ULA, NASA. Like, they keep theirs on the down low. They don't want everyone to know them for their failures. SpaceX, to an extent, doesn't either. But they want to show off the fact that they're improving. So, hence the highlight reel. Hence the constant Yes, Space Nicole. That was Mike Tyson. Yeah, everyone has a plan until they get punched.
Exactly.
Yeah, like you get punched in the face by reality. So it's an iterative process, and we need
Space
to
isn't
start
real,
that process.
you know.
Huh?
No, space isn't real. You know, you go out there, figure out.
It's all a simulation. Elon quote 2016 or whatever.
Elon is the one.
Elon is the one. How not to land an orbital class rocket, indeed. So
I'd be down to watch it actually.
Anyway, so that's about it for our news coverage this week. Go ahead, if you guys want to, post some questions in the chat. You can jump off, whatever. But we'll go ahead and search up, let's see, Mac Truck 6666. You were saying branch mining? Hello, Nathan. Walls, Minecraft.
Branch.
Maybe we should play Minecraft, right? I don't know. So branch mining. Oh, kind of like frack. The less what is it? The less controversial form of fracking. Yeah.
If you're new to Minecraft.
Yeah, let's use Minecraft as our.
Yeah. What?
Yeah, let's use Minecraft as the demonstration article.
There's a revolution being formed in the comments.
Yes, indeed.
Ugh.
SpaceX is literally benefiting from past failures of companies when the industry was very small and restricted. Yes, that is true. But I think what separates SpaceX in terms of the failures is that they're very public about it. And they don't want... They're keeping everything kind of close to the vest too. But I've never seen NASA put out a highlight reel, you know? I've never seen...
But see, NASA also doesn't hide it either.
True. Well,
their launches are public.
They're public. So
yeah. So
I mean, yeah. It'll be interesting to see future failures of SpaceX though, because obviously Starship is going to fail at least once. Whether or not that's a manned launch or not will remain to be seen. But I am expecting at least Starhopper to have one mishap because it's just such new technology. It's very.
Is SpaceX entirely privately funded? Because maybe that's the reason why SpaceX...
It's not necessarily privately funded. It's a private company, but it is funded by contracts from public institutions like NASA and the government.
Okay.
But in terms of private funding, yes, it does have private funding.
Because I was thinking maybe that's one of the reasons why SpaceX can afford to be so public about their failures.
Maybe.
Because
it's driven by private interests
Yeah.
and private people, so private individuals. So they can do whatever they want. Anyway, so if you guys want to jump off, you can jump off. But if you want to stick around, ask some questions, we'll be here for a little while. Let's see. Yeah, I just want to mention tomorrow we have design team meeting. So let's see. Is there a site that I can go to for design team?
Well, what do you mean?
So.
You mean the SAT-2 competition?
Yeah. Astronis.
Well, go to SAT-2.
Okay, so we're gonna talk a little bit. Let's see, small percent of the company to raise capital for BFR. Yes, they are. They are selling part of the company for BFR funding. Let's see, SEDS USA.
SAT-2.
SAT-2. So just a heads up, everybody. We do have a meeting tomorrow at 1:00 p.m. in the room 112 of the meteorology building, oceanography and meteorology. We will be going over. We will be going over this satellite competition, and we will be going over SEDS, Texas A&M SEDS team for that competition. Patrick, do you want to chime in here?
Yeah, so as you can see here is Alejandro showing you. This is the SAT-2 competition. So essentially, as I'm sure most of you all already know, but I'm just going to get into it again, just because I guess I like talking. But essentially, there's going to be 7 very, very strict rules that we're going to have to really follow, or guidelines that we're going to have to really follow, because those are the things that they're going to actually be judging us on. For example, we're going to need to be very, very, very stringent on the way we organize our things, on top of the fact that we also have to show them that not only can we design something, but we can also feasibly show them that, hey, we can actually build this. We have the funding allocated, everything set up. Yeah, he's showing you the rules right now. It's a lot easier. Now it's me that's showing you the rules. So if you notice, where is it? I was just reading it. If you look at the judges and Yeah, but it goes more in depth down here.
Eligibility, competitor, media rights, intellectual property.
So this is the RFP. We're going to be going over it tomorrow. Not super in depth, just because there's 12 pages, and I'm just going to be covering the real important things. So if you notice over here, so these are the things they're going to be judging us on. So the mission requirements, overall top level goals. Like literally what it is that we're going to be doing. So also just how we're going to be designing it, how we're actually going to be building it, what facilities we're going to be using, who our contacts are, who the people that are going to be investing in us are going to be, like where the funding is going to be. We're also going to be they're also going to be looking at, so how diverse is the team, because they don't want just engineers, because SEDS isn't just an engineering organization, it's an organization for everyone. So that's why they're going to be judging us on that. They're also going to be judging us on the ratio of graduate students to rice who, exactly, I don't even know who rice is or what they are. I like to eat rice. It's a very good food. Terrible university, just kidding. It's a great university.
No. They are a very, very good university.
Yeah.
We are not saying that.
TU, on the other hand.
Actually, no, we are. We wanted to say that Rice is working with us. I think SEDS Rice. They do have a SEDS chapter, and we hope to one day collaborate with them on a SEDS Space Vision. So anyone here who wants to look into that, join the club, and maybe we can work on that.
Watch JFK's.
I choose to go to the moon speech.
Not because it is easy, but because it is hard.
Actually, I'm going to, what is it? When was that speech given?
It was given in 1962.
1962.
Or 3.
No, it was 3. It was a
3.
It was actually right before he got,
we can, dude, you literally have Google right there.
Yes, Rice University speech.
Good private high school. Wow.
We choose to go to the moon and do the other things. September 12th, 1962. So actually 1 month before he was assassinated, he spoke at Rice. And anyway, going back to the satellite competition, yeah, we're going to do a 1U CubeSat, and we're going to put the payload that we're thinking of, we're not going to do... we're not going to decide until the rest of the team is on board, until the meeting tomorrow. So once we do that, we'll figure it out.
We're going to have some preliminary ideas, just to get the ball rolling, but it is eventually up to y'all to decide what exactly it is we're going to be doing, because after all, this is a Texas A&M venture, not a Patrick Ream or Alejandro Arroyo venture. So we're going to win this as a team, even to at every aspect.
Yeah, we'll have to win as a team. So we're going to be going to O&M 112 tomorrow to do the whole presentation and everything. First official meeting of the design team, and that'll be pretty fun. So
it's going to be dope.
Yeah, it's going to be dope.
Hey, do y'all want us to bring food?
Yeah, who wants food? Please answer no, because it's a lot of money. No, I'm just kidding. I guess RSVP, we'll add maybe, do you want to add a comment section or something on the RSVP thing?
See, I feel like it's already too late for that, because just
30 people already signed up for RSVP.
Yeah, or more than 30, but
more than 30 by now.
Yeah.
But so make sure to come tomorrow, 1 p.m. O&M 112, and we'll see you there. Other things going on in the world. Rolex 24, the Daytona 24-hour race for cars. They're not spaceships, but they might as well be, because they're...
The government just got unshut down for 3 weeks as well. So
government just got unshut down.
So for 3 weeks, there's now a new agreement that for 3 weeks the government is going to be functioning with all the funds. So NASA's going to be up and running again. Freaking 3 days after our career fair, but it's fine. It's not salty at all. No, literally the day after our career fair. So I'm not crying or anything, it's not terrible, but the Rolex 24 Hours at Daytona, do you know what teams are racing?
Mazda, Ford, Ferrari, Porsche. I know Cadillac has a few cars in there.
Oh, dude, Cadillac.
Cadillac, yeah, they built some prototype cars, and that's pretty cool. Let's see. Yeah, that's about it. Something to do. Launch updates. So, by the way, February 9th is supposedly going to be the launch day for Falcon
Wow, Micaiah.
Thanks. We care about cars. But,
Cars are dope.
All right. So Saturday, February 9th will apparently be the launch for Crew Demo 1.
Oh.
We'll probably do a launch party for that. 11 a.m. Eastern Time, so 10 a.m. Central Time. It may or may not be canceled because SpaceX is...
Just how it goes?
yeah, it's been canceled like 4 or 5 times. So...
Get the Spaceflight Now app.
Spaceflight Now. Wait, is this not up to date? I hope this is... Is this not up to date? Wait a minute. Okay. SpaceX DM1. The launch campaign on Reddit. Always the best way to get the most up-to-date information, because Redditors are famous.
Have no life.
I take offense to that.
I'm just kidding. I know. I
I'm
use
a
Reddit.
Redditor. I use Reddit, and I have a life. Okay. I think I have a life.
Name anything outside of space. You have a bed.
I have a bed. I have. I like cars. There we go.
Whoa! You can't show shirtless people on.
Oh, I don't know.
Actually,
It's ads, okay? I'm telling you, ads suck, okay? Ads, too many ads on the internet. They need to stop putting ads.
Don't you have an ad blocker?
Yeah, I do, but it doesn't block all the ads, okay?
Which ad blocker do you have?
Ad block. Oh my god! Don't tell me you have Ad Block Plus.
I do have AdBlock Plus,
Oh
but I also
my
have
God.
Ghostery, okay? So,
Oh.
sue me. SpaceX. Hopefully they put it onto their thing here. So they have a couple updates. Static test fire successful. The launch arm is there.
Oh my gosh!
Yeah, it's crazy.
It's so beautiful.
Splashdown. So we don't know. Well, I mean, they didn't update it on the time for their launch, so I'm just gonna go by SpaceX or Space Launch Now. So, or the space launch schedule, and I'm just gonna say February 9th because that corroborates something I saw the other day. So, we'll watch that, and then apparently there's supposed to be a first quarter or first half of 2019 launch of Falcon Heavy. So yeah, March, Falcon Heavy Arabsat 6A. That's going to be very interesting.
Nice.
I want to watch that. And then CST-100 Starliner is supposed to launch this half as well. So Boeing will be on top of that for Atlas V. Crew Demo 2 in June. There should have been an update for a second Falcon Heavy, but whatever.
So I have a question for you, Alejandro. Because they might not know this, but what got you into space?
Oh, my love of space is born of many years reading up on space planes. I love airplanes. Got into space planes. Got into Space Shuttle X-15. The Concept X-30, which was a space plane single stage to orbit developed in the 80s and 90s, based off of scramjet technology that never appeared anywhere.
Sad Boy Hours.
Yeah, sad hours. And then, of course, I watched Apollo documentaries and all that. KSP, yes. I super got into space in 2013 when I finally started playing KSP. I bought KSP and then my life went down the drain. I'm just kidding. KSP. I have KSP. I don't want to play right now. Maybe next week before the show. But I play a lot of KSP, and space to me. Like, I think it's really great because it's inspiring. It makes everything. It puts everything into perspective. And then my dream is going up into space and seeing the Earth, because the picture of Earthrise.
The Blue Marble.
Yeah.
Oh, Earthrise? Okay.
Earthrise to me is such a beautiful,
Yeah.
beautiful picture, and it's just like this beautiful thing. And you have the surface of the moon, and then you have this blue marble in a sea of black, and that's what gets me. That's what I love to see. And this is a more modern one, from a more modern. This was, I think, this was that laser satellite, the Lunar Reconnaissance Orbiter. Oh, okay, got it. So this was the LRO a few years ago, but yeah, pictures like these, and the idea that, you know, you can go into space and you can see things like that, and the idea of like going on an EVA and seeing the entire planet below you, like to get that, it's like the ultimate feeling of, you know, vertigo, but you must feel like, oh my god, it's so cool.
Oh my god, I have no control over anything.
I know.
Oh
like that would be so cool, you know. Okay. So February 23rd. Sorry, we got an update from the Twitch chat.
This just in.
Yeah, this just in. According to Everyday Astronaut on Twitter, DM1 is slated for February 23rd.
Wait, Everyday Astronaut?
Yeah, so Tim Dodd, the Everyday Astronaut. Great channel. Suggest you guys go and subscribe to him.
The guy with the binoculars, right?
I believe so, yes.
Yeah, I've been binge watching all of his videos recently. Dude, he actually provides a lot of really good insight. Yeah.
No, his channel is part of his own media company that he built off of this. It's basically a publishing or publicity company for space related tech. And if you guys want to, he does the more professional version of these what's it called? Of these podcasts, much like Scott Manley does much better versions of these. Scott Manley! Scott Manley does it, Everyday Astronaut. I like both of them. They're really great. Scott Manley is an astronomer by profession, so he does a lot of KSP videos, of course, but he does a lot of the space news and space technology reports. He did some on the Atlas and Delta upper stage engines, the RL-10. He talked about the Eclipse meteorite impact, some SpaceX news and all that. Fly safe, yes indeed. But Everyday Astronaut is more of a is basically like Scott Manley, but more of like general space news, not specifically about certain things. I don't remember his background specifically. I think he's film and photography background, hence why all of his photos are so amazing. Scott Manley is more of a technical background channel, so both of them provide equally cool stuff. Yeah. Anyway, back to Twitter. So Tim Dodd, let's go to his tweets and replies. Had to shoot, is it January 23rd? Okay. No, okay.
Somebody lied.
I don't think she lied. I think it's just like, it's somewhere on here. I don't know where it is.
We know where you are.
Okay, there it is. Yes, no, don't say that. We're not creepy. Okay, we're not creepy. We're
Look behind
no, Reporting. Okay, February 23rd. This sounds reasonable. Okay, so Ars Technica in Saigai Space. I mean, I don't know. Let me jump over to the foremost authority on
my gosh, Elon Musk.
SpaceX happenings. Moving past Tesla there. Wow. Now that is an 18-year-old birthday party photo worth getting.
Dang.
Many cold weather improvements for Tesla. That's cool. Interesting moose. There we go. Okay, so this came out today. This is them testing the heat shield for the stainless steel skin of Starship at 2,000 degrees Fahrenheit. That's insane.
Wait, but 2,000?
Yeah, so 1,100 degrees Celsius.
Yeah, but the space shuttle experiences temperatures way, 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 way hotter than that.
Well, on re-entry, it's designed to take up to around 1,500 degrees Celsius. So 1,500 degrees Celsius. And that's the design that they're trying to go after for stainless steel, for the stainless steel active cooling mechanism.
So then how are they re-entering?
Well, that's how they're re-entering. They're just re-entering, and that's how that's the temperature. Now, that's the temperature of the skin. The actual temperature of the plasma is, of course, way, way higher. Thousands and thousands of degrees higher. But the actual temperature of the skin, the heat that is absorbed by the stainless steel, that's much lower than the radiative stuff. Anyway, let's see. May be a month from commercial crew launch. So I guess public no earlier than date for the flight is February 16th. Thank you. They venting methane to create barrier while re-entering, according to the Twitch chat. I don't know about that. From what I heard, they were doing an active cooling setup with veins inside of and tubes inside of the actual skin. Actually, yeah. I guess venting a little bit of methane. I think I did see that, actually. Yeah, okay. So,
Interesting.
they probably won't rely on that, though. They'll rely on that as kind of, as a barrier. Kind of like the ablative barrier caused by most ablative heat shields. Those kinds of barriers, like, you'd be burning off a lot of methane.
Yeah,
because it's such a huge ship. It's 130 feet tall or something like that.
But see, if you did that, then that would also like reduce the reusability of the and increase the cost of.
No, it would increase the reusability because it create the barrier, right? So it keeps the heat from soaking into the steel too much. So it creates that extra barrier between the plasma and the ship.
See, I was of the understanding that the barrier was created by the panels burning off.
No. That's just normal. That's normal ablative heat shields.
Yeah.
Like Pica X, stuff like that. The space shuttle had special tiles that were composite tiles that could absorb that amount of heat without giving off too much radiation or heat into the structure of the space shuttle. This will be slightly different in that the stainless steel structure will have cooling veins inside of it. Bless you. And it'll run, It'll run the liquid methane and the fuel through those veins to cool down the exterior. So it'll wick away the heat using that fuel.
Oh, okay.
And then apparently, and I do believe that this is accurate. He hasn't given the presentation, so we don't really know anything. Mm-hmm. But according to some tweets, they will be expelling small amounts of methane along the skin of the rocket to create a kind of barrier like an ablative heat shield. Mm-hmm. But instead of using the heat shield itself, it's going to be using the fuel. Which is,
wow.
They're going to be expelling on a fuel, though, because it's a huge, huge spaceship. So it'll probably be used only for, like, the tip of the nose. Something that's, like, ridiculously hot, and that will be taking most of the brunt of the heat.
Yeah.
But then again, like, we don't know. We'll have to see. Maybe it'll do over the hinges so that the hinges don't get too much heat. We just have to see. So, yeah. Date is now February 16th or February 23rd, which is disappointing because I believe that I may be busy that weekend over there, and then...
See, you would think carbon, but there's actually superior, materials out there now.
You can do tungsten. Carbon is really good. The problem with carbon 1 is that it's not very strong, as seen by the Columbia incident where it got hit by the foam. But also, I don't know about the carbon for the nose. It could be a good use. The issue is that the way the re-entry profile is, it's going to be coming in basically perpendicular to the ground and perpendicular to the airflow. So Starship re-entry profile.
Because I know that Sierra Nevada, they essentially replaced the carbon on the Dream Chaser with, I think, a completely new Hola Fabricio with a completely new sort of material. I think I can't remember the name. It starts with the T. I was talking to the director.
Is it tungsten?
No. It's like It's a really weird name, but it does what carbon does, but many times better. That's why in the nose or the wings, they've essentially replaced where carbon would generally be with that.
Everything is always Reddit. These guys on Reddit spend way too much time doing these calculations. Like, oh my god. Like, this guy calculated the exact energy budget, or an approximate energy budget for the actual re-entry profile. This is ridiculous. These lecture notes, oh god. For everyone in aerospace engineering, please turn away.
I'm getting triggered just reading the name. Oh my gosh.
Get ready for some Diffie Q, right? No.
Diffie Q.
Nah.
Just aerothermodynamics is enough.
Stagnation point heat. Oh god, I don't have.
The stagnation point.
I have no idea what's going on here. Blunt body rationale. Okay, so I do understand that blunt bodies are better because they create a better shockwave. I believe, according to Connor, I think something about the wave drag or something like that. Shockwave propagation. Who knows?
Oh, I haven't learned that yet.
Yeah, I'm not. I'm not an aero, so gosh, we really need to get. Maybe we should have an aero engineer be here constantly as our
Shut up.
no as our like technical advisor to sit behind the screen and say no, get away, no.
You're
Or,
being stupid.
Correction.
Stop being stupid.
Okay. Let's see. Yeah, so this is the space shuttle heating profile. Blunt nose, of course. You have, let's see, capsules with their aerodynamic profiles. Come on, going on. All that math. Getting a... Okay, we're leaving that. Yeah, I mean, it doesn't have. I don't have any pictures or anything for the actual reentry profile, but it's supposed to come in basically belly first, belly forward, and yeah, like it doesn't show.
They just haven't released that much information, right?
Yeah, I mean they have.
Is that the Enterprise?
Oh god.
Nice.
Fall like a skydiver. Re-entry, presentation.
You should
ICE,
probably put
International
SpaceX
IAC.
Starship.
SpaceX Starship.
Just because then
Maybe, yeah.
to reduce the amount of...
So here are the presentation slides. Right? So this was from 2017. So it's a year old plus. Yes. Thank you very much. Coolio. Wait, was that it? No. So, okay, imagine it coming into the atmosphere like that. Not attached to the International Space Station, please. But imagine coming in belly first like that. That's what it's supposed to do. Like that, right there.
Yeah.
It's supposed to come in like that, and which is ridiculous. Which, it's insane. And...
Doesn't it use its winglets not for maneuvering, but to
Yes.
slow down?
Yes.
Yeah,
It's just like... I don't know what was going through their minds or something. I don't know,
I think their thought process is it badass? Yes, go do it. Honestly, because like how they're planning on entering Mars, just super freaking fast, going up and then landing. Like,
okay, so let's...
yeah, that's the video I watched. Yeah.
So let's skip forward. So he uses Kerbal Space Program to simulate. So yeah, this is not a very accurate representation. So it's gonna fall in through the, like that. It's gonna fall in like that, which is ridiculous. It's just like, are you serious, Elon? Like, this is gonna be the most insane re-entry profile ever, and it's like, but yes, it's ridiculous that the shuttle came in at a 45-degree angle, but it's like, it's still, you're how tall is it, SpaceX Starship? So the SpaceX Starship is what, 120, 150 feet tall. Let's see. So 55 meters times 2.2, so 120 feet tall, 110 feet tall.
Wow.
So, I mean, it's huge. And
Yeah.
this is going to be flying in at Mach 20. And 13,000 miles an hour plus, coming into the atmosphere of Mars. And
It looks straight out of like some 50s alien attack
Yes.
movie as well.
Yes.
I'm
But-
assuming that's not by accident either.
No. I mean, well,
Knowing Elon.
it's not necessarily by accident, but it is by design. Because obviously, like, maybe this was the only way that they can make it work, And they're trying to do it with today's technology without having to deal with, building new forms of engines, new forms of tiles and stuff, like a space plane, like a space shuttle. Like, those are the concepts that we always thought would be future spacecraft. But nowadays, we're thinking of something like this. So, I mean, it's going to be coming in at ridiculously hypersonic speeds, flying super fast, belly flop first, essentially. And, like, I don't know, man. It's...
Watching that, imagine.
riding inside of it, flying in belly first. Yes. Fabrizio, we have seen we showed a video earlier about the South Padre launch site and with Star Hopper flipping over. So, yeah, that was before it got tipped over. Unfortunately, I mean, look at that. Oh man,
Dude, that looks so like.
that looks 50s.
Yeah, dude.
That looks
Honestly.
I am so ready.
Wow.
I am so ready for this.
Like what?
I'm so. I mean, yeah. I mean, look at that. That's just like.
That looks straight out of like some sort of like 1920s. What the future will look
this
like.
looks like a. You know those like promotional like models that they make out of like the like or cast iron, cast steel or something like that. Models that they make for airplanes and stuff.
Yeah.
Like, you know what? American Airlines 2050.
Dude, it's because
American
honestly,
Airlines.
just how like straight it is. It's like there's no real lines to it. It's just a cylinder with a nose, and it's like
And with little flappy wings.
yeah, and no, they're not even wings, but just the freaking even weirdest part. It's like what the heck is that? Oh man.
I'm not gonna lie though, I am a little bit salty that it's not the original design, because I actually loved the original design. I thought it looked so futuristic.
Dude.
This original like, now that looks like a spaceship.
Yeah.
I mean, obviously this looks like a spaceship.
That looks like the Planet Express.
yeah. This looks yes. Next thing you know, Fry is gonna come out and talk to you about delivering pizzas and crap.
Dude, that'd be dope, honestly.
Yes, the original was way too big. Referring to the comments, yes, the original was way too big. But, like, come on. That'd be so cool. A 13-meter spaceship diameter, you know, enough space for, you know, small airplanes to be ferried into orbit in basically fully constructed. Like, that'd be so... 500 tons to orbit without reusability installed. Like, yes, I need that in my life. It's not going to happen anytime soon, but one day, yes, I need that. Like, I would love that. But, you know, dreams are dreams.
Well, I mean, they're not going to be dreams for
I mean, look
much
at that.
longer, right?
Look at that. Like, that is... Now that is the sci-fi universe that I signed up to
And
live
like,
part of.
imagine this. 1903, the Wright brothers fly.
Yeah. So what? We're not even we're
116 years later.
116 years, and we've gone from flying 150 feet or so to
It's like 30
we're
feet,
about to
yes.
launch an interplanetary mission.
Like literally
in the next 5 years.
66 years after the first flight, we landed on the moon.
Yeah.
So
that's crazy.
It is like just we are either about to be living in that stereotypical future, or we are living in that future and we just don't know it.
Yeah,
yet.
we're about to. We're basically living in that future. We're
Like
about to with
the
space.
Jetsons. We are the Jetsons.
Freaking Jetsons.
Except with like treadmills hanging off the side of like a 1,000,000-story building, because that's just stupid. But
Actually, no. There are concepts for floating cities on Venus.
what?
Yeah. So NASA came up a long time ago.
Don't let your memes be dreams.
Don't let your NASA Venus Balloon City. So they were actually coming up with this idea of sending balloons to Venus, because in the upper atmosphere it's actually very much like Earth in terms of pressure and stuff. The comments section says, "You hear about Blue Origin's new factory they broke ground for today?" Yes, I saw it. Thank you very much, Fabrizio, for your comment.
Thank you.
I don't know. I'll have to contact them. But anyway. Oh, okay. Yes, let's see. The new factory, like, I did see it earlier. Let me go bring it up. Oh.
We will be astronauts.
Blue
yes.
or Evolution. Oh god, is this Pokemon?
Blue or Evolution.
Okay. I'm gonna go away from that now.
What the blue or evolution? I don't even want to consider what that means.
Pokemon Blue? I don't know. Thanks to the votes of confidence from ULA Launch and U.S. Air Force.
Yeah, except hydrochloric acid clouds. Yeah.
Hey, you know what? If you don't have a little bit of acid on your walk to school, like, it's too easy. It's too easy.
Wait. Oh, Fabricio.
Yeah.
You
Pat, can you pronounce it right? My name. Oh. Wait, how do you pronounce it? How do you pronounce? Oh, stop laughing. Stop laughing. Shh. All right. Thanks for the votes of confidence from U.S. Air Force for national security missions and from Huntsville and the state of Alabama. We are breaking ground on a world-class facility to produce our engines, power the next generation of space flight. So this is in Alabama. So yeah, this is going to be building BE4 and BE3U. Yeah. So they're going to be building the new Glenn rocket engines. So for those who did not watch the last week's episode, I talked about New Glenn. They released a new video. Let's see. So this will be their orbital rocket. Yeah,
I'm assuming this is a This
is a render.
Yeah.
It will be powered by 7 BE4 engines, each one producing 550,000 pounds of thrust. And those engines apparently will be built in Alabama. And,
Damn.
Probably tested in Alabama too. I mean, Alabama has a huge history of engine tests. Marshall Space Flight, what is it? Yeah, Space Flight Center for NASA. Aerojet Rocketdyne, though, I don't know where they are. Maybe they're in Alabama.
No, I thought they were like in California or something.
Is Aerojet Rocketdyne in California? Or?
Not. Well, I can look it up really fast.
Yeah, look it up.
Because like it's.
And then you have what is it? And then you have like Morton Thiokol over in like Utah or something. Anyway, yeah, that's about it. I think we're pretty much done.
Yeah, so it's California, Sacramento, California.
All right. They signed a deal with Marshall Space Flight Center to test on their Saturn V test engine stand.
Wow.
Ooh.
Dang.
That's very good. Thank you very much for that information. Yeah, so that would be... Saturn V test stand. That'd be this guy.
Wow.
This massive unit.
Dude, all the history behind that, man. Like,
I mean, look at that. That is the best flamethrower in existence right there.
Dude, like...
One day.
Can you imagine how loud just that must be?
Oh, yeah. No, I mean, we were discussing it in the general meeting the other day. Remember, we were talking about the sound. If you stood 1,000 feet from the launch pad or next to those engines, your body would literally be shaken apart. Yes.
Dude, the Harlem
referring to the comments, yes, it is not a flamethrower.
And it's a flame chucker?
Chucker, yeah. Chucky, chucker, whatever. Yeah, look at that. Like, if that doesn't make you, like, giggle, if that doesn't make your inner 5-year-old squeal with happiness, I don't know what does.
Just the sheer amount of power.
Yeah, this is literally like, and what is it? Actually, there's a Saturn V test
explosion
or engine.
Lego Saturn V test.
Yep. All right, so here is the Saturn S1C. Look at this. So this is old. I won't turn on the music or the sound because that's too insane. But here it is. 3, 2, 1, whatever. There we go.
Oh, you were on.
I was right. I was right on. Look at that. Look at the sound waves like destroying the clouds. They're just so powerful. It just dissipates all the clouds. That's 5 F1 engines, 7.5 million pounds of thrust. Like, to be around that must have been just insane.
And the sheer amount of like courage it takes to stand or to sit on top of one of those rockets. Jeez.
3 guys strapping their asses to the top of that rocket.
Like, imagine the minute it takes for the elevator to take you to the top, you know, maybe I chose wrong.
Is this such a good idea, guys? Calling up Werner von Braun. Yo, man, you sure this thing's gonna work?
This thing is really tall, actually.
Yeah, and there's the engine gimbaling for all 5 engines.
Oh my gosh.
Let's see. Here's the actual view from the engine room, so to speak. Look at that. 5 off 1. You initiate and kaboom! Oh my god! Like,
see, what's really interesting?
Look at that.
Like they even had to figure out a solution to actually be able to record it. And essentially, what they did was that they had a camera pointing at a mirror that was then reflected to the engines themselves. So it's like literally every single thing they had to come up with a freaking duct tape solution to.
yeah, they had to work around it, otherwise everything would explode.
Dude,
So, yeah, these things were absolutely insane. And, you know, harken back to an age, you know, when, what is it? When America made stuff. We still make stuff. It's just
not the right stuff.
not the right stuff yet. Yeah, we're getting back to it, though. We're getting back to it. And, like, look at that. Like, I think that's actually, like, the exhaust from the pre-ignition, the pre-combustion that drives the turbo pumps flows into this exhaust vein to coat the inside of this engine bell to cool it, to provide a barrier between the combusted plume and the engine bell. This unburned or just pre-burnt fuel that's like cooler than the rest of it, that's what keeps the engine bell from melting. Look at that plastic or piece of paper getting annihilated.
Bye-bye.
So, what is it? My favorite was, what is it? The Delta Launch Frog.
Oh no!
This guy.
No! No!
This man.
No!
To quote, what was his name?
Kermit. No.
What is it? The Rocket Man? Oh, crap. Wow. I am so bad right now. Rocket Man, the song. There we go. Elton John. Oh my god, I'm so stupid. So Elton John, yes, this frog is the Rocket Man.
Dude, like...
Not Starman, Rocket Man.
for like a few seconds, the frog, it was the most badass frog that has ever lived, and then it died. But I mean, for those few seconds.
No, speaking of that, there was
a bat, right?
Yeah, Space Shuttle bat. Yeah.
Yeah.
At least I think it was. Yeah, there we go. Space bat. I think this is a good thing to end on too, since we're getting a little bit long in the tooth here.
The space.
Yes, there was a bat that hung on to STS-119's main tank.
Imagine you're in your bed, you know, you're sound asleep, right?
The engine starts like, whoa,
your bed starts shaking, it starts lifting up. Like, I can just imagine what's going through that bat's head.
You know, it makes that, you know those alarm clocks they sell you where the alarm clock falls off the table and you have to go get it? This would be a much better alarm clock.
Get off the rocket before it takes off. No. Okay. I think this is a really stupid thing to end off on, but it's really relevant. I think it was...
What is it?
It's Bugs Bunny when they built the rocket stand on top of his hole that he lived in. And
oh my god. Okay, we'll save that for next time. But okay. Yeah, I think that's gonna be it for us tonight. Thank you very much. Rip the animals. Yeah, thank you very much for watching, guys. And I think that'll be it.
Tamo Fabricio.
All right. Thank you very much, and catch us next week, 8 p.m. Friday, February 1st. Actually, yeah, February 1st. Ring in the new month. Woo! So, yeah, thank you very much, and have a wonderful night.